Hello children, welcome to AIMS India's online classes. In today's video from mathematics subject, quadratic equations topic we are going to discuss. So our today's concept is regarding condition for common roots. Condition for common roots. Suppose if we consider two quadratic equations in the form of a1x square b1x c1 equals to 0. This is one quadratic equation where a1 is not equal to 0, because if a1 is 0, there will be no x square term. It will not be quadratic. So that's why this condition we have to keep in mind, where a1 is not equal to 0 and a2x square plus b2x plus c2 equals to 0, where a2 is not equal to 0. So in this form we have two quadratic equations. If one root is common to both equations, then suppose if one root, because quadratic equation means normally it contains two roots. Normally it contains two roots. Here the equations are different, so the roots also will be different. But here we have to consider at least one root is common for both the equations. Out of alpha beta values, root values for first equation and alpha beta values for second equation, if one root is common, one value of x is common in both the equations, then we have to prove this a1 b2 minus a2 b1 into b1 c2 minus b2 c1 equals to c1 a2 minus c2 a1 whole square. This we have to prove. So the given equations children, this is the first equation, let it be 1. Second equation, let it be second equation. So the equations 1 and 2 have one common root. One common root. So then by using cross multiplication method, what we can derive from these equations is, here x square term, x square term, we have to take it separate. Then what will remain? X term will remain, constant term will remain. So b1 c2, c1 b2. So x square term we have to omit, and remaining terms coefficients we have to multiply, cross multiply, and next we have to take x. Now x term we have to omit. After x term we have c1 c2, and this a1 a2 will come this side. If we write them after this c1 c2, and if we do cross multiply, then we can have c1 c2 a1 a2. So next if we omit constant term, then what is remaining? a1 b2 b1 a2, a1 b2 b1 a2. Means if they have one common root, so then they can be written according to cross multiplication method in the form of x square by this difference of this cross multiplication products, b1 c2 minus b2 c1. So x square by b1 c2 minus b2 c1. In the same way, x by c1 a2 minus c2 a1 equal to 1 by a1 b2 minus b1 a2. So this one equal to this one equal to this one. So like this we can write if they have one common root. So then let's take this first term, and this third term. Let's write them together and let's do cross multiplication, or let's take this denominator below x to RHS part. So then x equal to C1A2 minus A1C2 by A1B2 minus A2B1. This expression will come. This expression will come. So, and sorry children, this, if we compare this second and third, this expression is coming. If we take first and third, this will go towards right side, and x square will become equal to this one. We will get this one. So here we have x value, here we have x square value, but we have already got x value. So in the place of x, we can keep this value. So what does it become? C1A2 minus A1C2 by A1B2 minus A2B1 whole square equal to this expression, this term. Again, so here denominator, it will come 2 times. Denominator, it will come 2 times. But the denominator here and the denominator here is same. So if we write separately, C1A2 minus A1C2 whole square by A1B2 minus A2B1 whole square will come. But right hand side denominator also we have the same term. So if we cancel it, it will be cancelled one time. So only one time will remain. So this one time will go to the RHS and will multiply this one. This will remain only one time, and it will go to RHS and multiply this one. So here square will remain. Here 2 times it will remain. So we have got, as per the data, what they have asked us to prove, that we have got. But we have done with the help of cross multiplication method. So this is the condition, children, for one common root. This is the condition for one common root. If this condition is satisfied, we can tell that both the quadratic equations will be having one common root. Next, two quadratic equations having two common roots. If they have two common roots, so if they have two common roots, then what, children? 1 minute. This value will become 0. If they have two common roots, this value will become 0. Or they will be having two common roots if this condition is satisfied. A1 by A2 equals to B1 by B2. If this condition is satisfied, or indirectly, if this condition is satisfied, then we can tell that they will be having two common roots. So in this equation is applicable if they have one common root. Two common roots means indirectly they will be having one common root. We can make use of this condition, and if this value will become 0, we can keep 0 in that place. 0 into this value, it will become 0. This total value will become 0, and this one, C1 by C2 equal to A1 by A2, this will come. So A1 by A2 equal to C1 by C2, A1 by A2 equal to B1 by B2. Indirectly, A1 by A2 equal to B1 by B2 equal to C1 by C2. Means, if two roots are common, so then this condition should to be satisfied. A1 by A2 equal to B1 by B2 equal to C1 by C2. Or if f of x equal to 0 and g of x equal to 0 have common root k. If the common root is k, then in the place of x, if you keep k, then f of k value will become 0. In the place of x, if you keep k, g of k will become 0. Or indirectly, f of k will be equal to z of k. F of k will be equal to z of k. Next example question. If x square plus 4ax plus 3 equals to 0 and 2x square plus 3ax minus 9 equal to 0 have a common root, one common root, then find the value of a. Find the value of a here, and the common roots. And we have to find the common roots. So the condition for two quadratic equations having common root is this condition. Just now we have proved. But the given equations are these two. The given equations are these two, where if this is a1x square b1x plus c1, then a1 equal to 1, b1 equal to 4a, c1 equal to 3. In the same way, a2, b2, c2, we can have the values. If these values are substituted in this condition, if they are substituted in the condition, after simplification, we will get 225 equal to 225 a square, or a square equal to 1, or a equal to plus or minus 1. A equal to plus or minus 1. The value of a is either plus 1 or minus 1. So if a equals to 1, then the equation will become x square 4ax, 4 1x means 4x plus 3 equal to 0. That can be written as factors x plus 1 into x plus 3 equal to 0, or x plus 1 equal to 0, which means x equal to minus 1, x plus 3 equal to 0, x equal to minus 3. If and second equation, 3ax, if a is 1, then 2x square minus 3x minus 9 equal to 0. This can be written as factors 2x minus 3 into x plus 3. So 2x plus 3 equal to 0 means x equal to 3 by 2. X plus 3 equal to 0, x equal to minus 3. So for first equation we got values minus 1, minus 3. For second equation we got values minus 3 and 3 by 2. First one, second one. Out of these two roots, the common root is minus 3. The common root is minus 3. Like that we can solve the problems. Next one. So next example. Solved examples. Solve x square minus 6x plus 5 equal to 0 by using the formula. So comparing the given equation with the ax square plus bx plus c equal to 0, if we compare with this, then a value will be 1, b value will be minus 6, c value will be 5. They are asked us to solve the problem. Solve means we have to find x value by quadratic formula method. So roots of equation are, or roots of x are, we have the formula minus b plus or minus root of b square minus 4ac by 2a. We have this formula. Already we know ABC values. We can substitute them. Minus of b value minus 6, which becomes plus 6, plus or minus, in the place of b square minus 6 whole square, minus 4 into a value 1, c value 5 by 2 into a value 1. Let's substitute all the values. Then 6 plus or minus, minus 6 whole square, minus, because exponent is even, minus will become positive. 6 square 36, 4 into 1 into 5, 20, which is equal to root 16. Root 36 minus 20 equal to root 16, which is equal to 4 by 2 into 1, 2. 6 plus or minus 4 by 2, which means 6 plus 4 by 2 or 6 minus 4 by 2. 6 plus 4 by 2 means 10 by 2, which is equal to 5. 6 minus 4 by 2 means 2 by 2, which is equal to 1. So 5 comma 1. So the roots of equation are 1 comma 5 or 5 comma 1. Next one, solve. 8 minus 5x square minus 6x equal to 0. So, but this is not in the standard form. In standard form, x square to be written first, next x term, next constant term. So, let's write it in standard form and compare with ax square plus bx plus c equal to 0. Then a will be minus 5, b will be minus 6, c will be 8. Now, for finding the roots of equation, we can make use of quadratic formula. Minus b plus or minus root of b square minus 4ac by 2a. Let's substitute the values. Minus b means minus of minus 6 plus 6, b square minus 6 whole square, minus 4 into a value minus 5, c value 8 by 2 into minus 5. 6 plus or minus, minus 6 whole square 36, 8 5 times 40, 44 4 times 160, 36 plus 160 by 2 into a, 2 into minus 5 minus 10, 36 plus 160, 196, root of 196 equal to 14. So 6 plus or minus 14 by minus 10, which means 6 plus 14 by minus 10 or 6 minus 14 by minus 10. So 20 by minus 10 equals to minus 2. Minus 8 by minus 10 equals to 4 by 5. So the roots are minus 2 and 4 by 5. These are the roots. One minute, children. Okay, children. The chapter is completed, children. We have concepts, definitions and formulae. Let's revise the concepts, definition, formulae or CDF points from this chapter. What we have learned so far. If ABC belongs to R, real numbers, and A is not equal to 0, then the expression ax square plus bx plus c is called quadratic expression. And a real number alpha is said to be 0 of expression or root of expression or solution of expression ax square plus bx plus c if in the place of x, if we keep alpha, if it becomes 0, then it is called root of the expression. We have ax square plus bx plus c. In the place of x, if we substitute alpha, a alpha square plus b alpha plus c, if it is equal to 0, then alpha is called root of this expression. So if ABC are real numbers and a is not equal to 0, if this expression, if this quadratic expression equals to 0, then it is called quadratic equation. Without 0, it is called expression. Equal to 0 with equality symbol, it is called equation. So the value of variable x for which this equation is satisfied, already right hand side we have 0. If we keep which value in the place of x, left side LHS part also will become 0. That value of x is called root of the equation, solution of the equation. So the roots of quadratic equation are, we have a quadratic formula, that is minus b plus or minus root of b square minus 4ac by 2a. If we take plus, we will get one value of x. If we take minus, we will get another value of x. So in this quadratic formula, the value b square minus 4ac, which is under the square root, it is called discriminant of the quadratic equation. It tells about the nature of the roots. Roots means here x values, alpha and beta. This discriminant value tells about the nature of roots, whether they are real numbers or whether they are complex or imaginary or equal. Like that, their nature, this discriminant will tell. So if ABC are real numbers, so nature of roots depending on discriminant as follows. If discriminant value is less than 0, then the roots are non-real or imaginary or conjugate complex numbers. The roots are not real. If the discriminant is negative, roots will be imaginary or complex numbers. If the discriminant value is 0, then the roots are real numbers and they are equal. Both the roots will become equal to one another if the discriminant is 0. If the discriminant is greater than 0, then, and if the discriminant is perfect square, two conditions. One, it should be greater than 0 positive, and it should be perfect square, means it can be written in the form of a square, so that square root and square get cancelled. At that time, roots are rational numbers and distinct. Both are different. So if discriminant is greater than 0 and discriminant is not a perfect square, so then the roots are irrational numbers. If they are irrational, they are conjugate to one another. Means if one is a plus root b, another one is a minus root b. If you multiply both of them, this root will be cancelled. Then they are called conjugates. If it is a perfect square, then the roots are rational and distinct. But if it is not a perfect square, then the roots are irrational but conjugate to each other. Means if you multiply both, they will become rational number. Product will become rational number. Though they are irrational, their product will be rational. They are called conjugate. Next, if alpha, beta are the roots of this equation, then alpha plus beta equal to formula minus b by a, which means minus of coefficient of x by coefficient of x square by coefficient of x square. Alpha beta equal to c by a. Sum of roots minus b by a, product of roots c by a, where c for constant, a for x square coefficient. If you know the roots alpha beta of equation, quadratic equation, then quadratic equation can be written as product of x minus alpha into x minus beta in terms of roots. Or if the roots of quadratic equation are alpha beta, then the equation is x minus alpha into x minus beta equal to 0, or x square minus sum of the roots into x plus product of the roots equal to 0. So quadratic equation can be written as product of these two factors involving roots, or if you know the roots, then we can write the equation. From the equation we can find the roots. From the roots we can find the equation. So we have formulas for alpha plus beta and alpha beta. In the same way, we can deduct formulas for, or we can derive formulas for alpha minus beta, difference of roots, equal to root of alpha plus beta whole square minus 4 alpha beta, or alpha square plus beta square equal to alpha plus beta whole square minus 2 alpha beta. We can make use of these formulas while solving the problems. So the condition for common roots, is, so one common root will be either this one or this one, because this is equal to this is equal to this, indirectly means if this is written as a product of two factors, same factors, one will come down, one will go down, then this fraction will be equal to this fraction. Both will become equal, or one common root will be either this one or this one. If two roots are common, then this condition they have to follow. Or if f of x equal to 0, g of x equal to 0, if they have common root k, then f of k will be g of k. So these are the concepts, definitions, formulas, children, which we have learned in this chapter. So let's solve the problems in our next video, children. So children, thank you for watching our video. Please subscribe our channel and press the bell icon for receiving latest updates. Thank you, children. Have a good day.